Okay, here we go. We're going to take our equation from -1 to 3. Going to rotate around y equals -2. So y equals -2 is going to be 1, 2. So it's this equation right here. Now, if we're going to go around this way, when we deal with y equals -2, it functions like an x-axis. So when it functions like an x-axis, we can use dx. Now, when I do this, though, 1, 2, it will be definitively a washer because I have an area up here, I have an area down here. So I need outer radius minus inner radius. So we're going to have integration of pi outer radius squared minus inner radius squared, and it's still going to be dx. Now, outer radius, well, if I just had f of x, that would be right here. That's f of x. But the problem is I have more than f of x. I got this entire space here too. Well, that space is too big. So we're going to say f of x plus 2 would be the outer radius every time. And the inner radius would be 2. And I say, well, why can't I just cancel those out if I just have a subtraction of squares? Well, order of operations means you can't do that. So if, again, I go from -1 to +3, because we're back in terms of x, I should be able to work that out fairly easily. Let's go ahead, and that was part D. Let's go ahead and do part E. And part E is y equals 4. Now, yuck, 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 because I'm going to have this. Y equals 4. That's 5, that's 1, that's 0, that's 3, that's -1. 4, oh, it goes right through there. So now again, I have the same problem of doubling over area. So in this case, will this area, when rotated, entirely cover this area? The answer is, yeah, it will. So I don't really need to worry about that bit. Now, we're still going around an x. Okay, we're still going around an x in essence, even though it's y equals 4. So it's going to be, disk or washer. Well, it's going to be both, because again, at this point here, from here over, it's disk. From here over, it's washer. So I'm going to need to do a washer, pi, let's move it down so I have plenty of space. Pi big radius squared minus little radius squared dx plus this portion here. So I'm going to have a chunk that looks like this. So I have a chunk that looks like this, and I have this chunk over here that looks like this. So it's going to be a small, flat disk shape. So in this case, plus pi r squared dx. Now, the nice thing about this r is, well, it goes up to 4 the entire time. So if that's constant, then it's just 4 squared. Yay! Okay, and it's from where to where? What x to what x? Well, we need to figure out, where does this hit 4? So we say 4 equals x plus 2, and not shockingly, it's from 2. So from 2 to 3, you use that. From -1 to 2, that would be this area, you would use that. Outer radius, well, the outer radius would actually be a total of 4. So the outer radius is always 4. So 4 squared. Now the inner radius becomes a problem, because if I just do f of x, that's going to be from here to here, from here to here. But I need the inner radius to subtract. So how do I get an inner radius rather than this bit down here? Well, if I want just that, if I need just this dimension, I need to take the entire 4 and subtract whatever f of x is, and that should leave what I need. So we're going to say f of x minus 4, 4 minus f of x. So 4 minus parenthesis f of x, we're back to x plus 2 here. There you go. And so we put all that together, but you'll notice we're breaking things into chunks. We're breaking things into components. And that's what's necessary here. All right, we'll deal with plane slicing next.